Okay, let's begin by looking at DNS troubleshooting tools. This is going to be part of section 3, talking about test and troubleshooting as part of the F5 DNS exam blueprint. So we'll go over F5 DNS blueprint objective 301, which includes topics around OpenSSL, TCP dump, SSL dump, dig, and NS lookup. Okay, let's look at that F5 DNS exam blueprint. Make sure we cover our bases here. So Objective 301 states to determine when and how to employ the appropriate network and DNS troubleshooting tools. So specifically, we're going to talk about using OpenSSL to review trusted CERT information, look at TCP dump to analyze DNS and iQuery traffic on appropriate VLAN and IP, and then use dig/NS lookup to verify DNS configuration and operation. Okay, so let's look at OpenSSL/device certs. So device certs are the key operation to support iQuery. So if the certificate is expired or if it contains duplicate CNAME entries, then it'll actually mark that system as offline, and you can find that message in the var log GTM. It will state something along the lines of this SSL3 get server certificate verify failed. Okay, and you can, one of the things you can do from the command line is using OpenSSL in the X509 format to check the validity of the server.crt. This is the local device's certificate. So you can check the validity date on that certificate and then run this on all big IP devices that participate in that sync group. So I'm going to show you where this is currently at in the GUI. If you go to, this is a version 14 VE F5 Big IP platform, and you can find the device certificate in the GUI as well by going to System, Certificate Management, Device Certificate Management, and then Device Certificate. Okay, so currently the default certificate or self-signed cert is on the box. We can choose to renew this and include our proper CN down here, and organization, the rest of the subject details. So let's go ahead and click renew. Alright, and what I usually like to do is put the host name as the common name. Usually it's FQDN, so it would be like Big IP 1, maybe .local if this is just on the local network, and we'll just put okay. We'll leave the email address as the root. That's fine. The lifetime, F5 suggests if you're using iQuery, we want to typically extend the lifetime of this certificate, because if you do need to renew it after it's in production, it will take a maintenance window event to renew the self-signed certificate. So in our purposes, we're going to use 10 years or 3650 days. Okay, we'll just leave the SAN property blank. We'll click Finish. And because we just created that new self-signed certificate, it's prompting us again to use the new certificate in our browser. Okay, and notice it did have the default public key size of 2048 bits using an RSA public key type. Okay, well now let's jump to the command line, and I'll show you what the OpenSSL command can verify. So you see some options here. The OpenSSL, we can use the standard commands here. OpenSSL X. Well, first we specify the type that we want to use for the certificate. out text in config httpd conf ssl.crt /server.crt. Okay. Okay. Now we just see the information we just created. Notice the organization and the organization unit is specified here with our proper CN, and you can see the validity date is before September 3, 2018, and it expires at the approximately the 10-year mark on 2028. So if you wanted to run this OpenSSL command on each one of your F5 devices, that way you can verify first off that this information is not expired, and if it's an older version, it may not use the new 2048-bit public key, so you may want to renew that. But OpenSSL is a good command to use for to verifying the self-signed certificate. Okay, so now let's take a look at TCP dump events for big IP DNS. Take a look at the first one, TCP dump -NNI. So N is not resolving IP addresses to names. The second N is not resolving ports to names. -I indicates what interface you'd like to collect on. In this case, 00, we're going to use all data ports on the big IP platform. -X is, so when you're parsing and printing the actual data in the headers, this will print the data of each packet minus the link level header in hex and ASCII. It's a nice way to analyze newer protocols. The -S is snaplin. We're setting the full packet length. 0 specifies the full 655.355 packet length, and then port 4353 is the standard iQuery port on TCP. So that is an example iQuery connection, and the traffic is going to be encrypted, so you won't see the actual packet information unless we use SSL dump, which we'll get to in a little bit. Okay. All right. So second example, we're doing the same part of the first one, but in this case we're specifying port 53 going to a specific GTM listener. So say you have a UDP listener, you expect to see traffic or DNS traffic on your big IP device. You can see DNS requests and responses. All right, next is the TCP dump. There's NNEI. E specifies or captures link level headers, which includes MAC addresses. So you can use that if you're troubleshooting more of a link issue or ARP layer 2 type issue. And then it'll only display packets that are for VLAN 100. Okay, this next capture identifies E0, which is an alias for the management interface. So the 00 captures on all data ports, but it does not capture on the management interface. It's more of a control plane interface on its own. So the E0 must be specified in order to capture on the management interface. And here we're specifying only display packets that include port 53, which is DNS, and then write to a file called mgmt.cap. So maybe you have the DNS box locally is doing DNS requests outbound off its management interface, and you wanted to verify something to do with that, then you could run this capture. And then TCP dump-R is after you take and write a TCP dump to a capture like mgmt.cap, and you want to look at those contents locally, then you can do a TCP-R to read the contents. It's a quick way to read just the plain text of the capture. If you know exactly what you're looking for, maybe you want to grep on the exact error or header information, then you can do a -R instead of copying that file off to a local system, and then you can run a protocol analyzer on that. Okay, so those are just some examples to run TCP dump for specifically for big IP DNS. Okay, well, let's talk about if we can decrypt iQuery traffic. So is it possible to decrypt iQuery? Well, you can. There are a few caveats that will prevent this from making it very easy. So first off, iQuery is encrypted using AES, and in order to use SSL dump, this current latest version release does not support AES. So you have to find the CVS version to actually do the SSL dump. So this indicates that you need to copy that capture from the F5 to an external Linux client to run the SSL dump, because as of Big IP version 14, that currently supports the same SSL dump version. So you can't run the SSL dump locally on the F5. All right, the next thing is you have to use the web server certificate key from the server. So it might confuse things when you're trying to run the SSL dump, is that when you are running the SSL dump, you also need to get the server certificate key from the F5 remote system. So you also need to copy this this key to the Linux client if you're trying to do the SSL dump from that. All right. So now to decrypt SSL, you do need it must include the initial SSL handshake, or else it's not going to be able to decrypt that SSL transaction properly. In order to do that, you would need to restart Big3D or GTMD, depending on if you're doing a local from the local or remote system. The local is the GTMD, would be the local Big IP, and the remote Big IP would be Big3D. So you would need to restart one of those processes, and depending on who is initiating, you would only need to restart one side, but whoever initiates the SSL handshake, that would be the one you would need to restart the daemon from. Okay, and now say we've decrypted that data successfully with that SSL dump. Well, the XML data is actually compressed with the zlib before it's encrypted. So in order to decrypt, we have to extract the information from SSL dump and run it through a decompression tool. You can use it's possible to compile zlib into the SSL dump that you're running to make it a little quicker for that tail end. So if you want to go through that process, and F5 support may have a cleaner way. If you're doing something like this, you may want to contact F5 support, because if you're already digging into the weeds a little bit, you're probably going to need their assistance if it looks like more of an internal bug, right? So the better options for clients in general, or partners, is to use IQDump to see the probe responses, and then if you want to see both the probe requests and responses, you can debug the GTMD Big3D, and then look at varlog GTM. I think this is far better than going through the above steps for decrypting iQuery traffic. It's obviously a lot faster to do this latter option, but you may run into a case where that you may need to look into decrypting iQuery for a specific reason. So I wanted to give you these steps. Alright, so in conjunction with that last slide, I talked about some better options, one of those being the IQDump utility on the F5 platform. So basically, F5 IQDump subscribes to the Big3D process by creating a separate iQuery connection. So it basically listens for everything going on that specific process. Okay, so we can run this IQDump against a remote Big IP self IP, and if it returns, an error like we saw from the previous output, maybe we can do an OpenSSL on that specific certificate via the local or remote system to verify that it's not expired or nothing's wrong with the certificate in general. Okay, so to verify the actual iQuery channel is established, it would show more results with the XML similar to the following. So it's going to subscribe to a sync group, which by default, the default name is default. Okay, you should change this name before doing a sync. Okay, but it's going to connect to that big 3D process on the given remote big IP self IP and look for that XML information being sent across. And this again will display probe responses, not necessarily probe requests. So again, in order to look for probe requests and responses, you could turn on the debugs for Big3D and GTMD to see a little more detail.